Good day. My name is Roobakkanthan. So today, I and my group mate would like to present about Let 5, which is cryptography and certificate. So for my part, I'm taking the part 1, which is about the big numbers and brute force attack. For the first part, the calculation is first we need to find the possible number of keys, which is 1.1 times 10 to the power of 12 keys, and then we must change to convert to keys tested per second. Then for the third step, we need to find total time of all keys, and then from seconds to minute and minutes to hours, and convert hours to days. So which is total 12.73 days approximately. As for the 1.2 is same steps for the we follow in 1.1. So we need to find the possible keys, then calculate a key per seconds, and then total time of the keys. From seconds, I straight away convert to days, which is I simplify the step from seconds to minute and minutes to hour to days. So which is we needed 3.93787 times 10 to power of 27 days. So the results show how long it would take a conduct, but with current processing capabilities, the result time periods are unfeasible to their extreme length. For the 1.3, 1 year is approximately 3.154 times 10 to the power of 7 seconds. So for the 14 billion years, it will be 14 times 10 to the power of 9 years. And then we calculate both of them. We got the 4.416 times to the power of 17 seconds. So that means the time required to brute force attack is about 7.7 times 10 to the power of 14. That's times longer than the age of universe. So which is the time of the question in the 1.2 is much more longer than the our age of universe. For the question 1.4, for the first one, we should calculate the keys tested per second. And then we need to find the total time of the all the keys as the calculation shown here and convert to the years, which is 1 year approximately 3.154 times to 10 to the power of 7 seconds. So total is 10.79 trillion years. So it is yes for the question. Secrets are still safe from the attack is about 10.79 trillion years. For the question 1.5, we calculate the time it will take try all the possibles for 128 bits AES sealing keys. This is the calculation for the doubling. T equals to N over SO times 2, which is SO is number of the keys, and which is 6.81 times 10 to the power of 32 seconds. So seconds to years, which is approximately 2.15 times to the 10 to power of 25 years. So this duration far exceeds the current estimated age of the universe, which making such a brute force attack practically is impossible. So as for the extra credit question address the physical reasons why 192-bit or 256-bit shared secret would provide more security than a 128-bit shared secret in the context of AES encryption. The longer key length significantly increases the number of possible keys, making brute force attack impractically and time-consuming, thereby enhancing security. So that's all for my part. Thank you.
Hello, everyone. My name is Za'im Hakimi, and today for my part, I will explain about part 2, about Cryptography hashing. Okay. About cryptography hashing, I will explain a simple explanation about hashing. Hashing is about process of converting of input of any length into fixed size of string. It means that we can put any text, no matter how long, short, or more long. It can be converted to array of number and later truth algorithm. So for this part, to show you, we need to create a word. Let's say for the task 2, I will show you. In this, I put the input type of text University Technical Malaysia Melaka in the notepad, and I'll already save in the save as motd.txt. So right now for this notepad, I already save in the lab. If you can see at the left, this is the CMD command prompt, which I will show you the experiment of this lab. So now I already put in the lab file, which means it already in the desktop. So for execute, we must first to put the command, which this command certificate hash file motxt sha256. So let's say now I copy this command and put here, and now I will enter. So if you can see, the hashing is already successful command. So if you can see from here, from which I highlight, this is the result output of the hashing, which it's transfer from the input text. It will be convert through the hash function, which it will changing the input text into the number and letter. So this is the result output of the hashing. If you can see the which I highlight. So now for the task 2, let's say I change it in the notepad. So first, I copy this word, and then I will paste in here and I save it. So now let's say we try again, execute the same command. And now you can see at the output, the output is changing because we change it the text in the notepad. So if you can see in the question 2.3, it says what we can observe between question 2.1 and question 2.2. The reason is due to the file modification, which file will modify between Q2.1 and Q2.2. Like I said, if we change any text or adding or remove any single character, it will result a completely different hash. So that's why for the first part, we only put the university, and then for the second part, we put the word from this. So that's why if you can see the difference of the question 2.1 and question 2.2, the result output is the different. So that's all about the hashing, which mean is the process of converting an input of any length into fixed size of string. So that's all for me. Thank you.